Yeah, hello everyone, and welcome to our today's episode of Advent of Code. Day 6, I think we should have, and as always, we are trying to solve this in Go. Okay, let's take a look at our today's puzzle. Tuning trouble. The preparations are finally complete. You and the elves leave camp on foot and begin to make your way toward the Starfruit Grove. As you move through the dense undergrowth, one of the elves gives you a handheld device. He says it has many fancy features, but the most important one to set up right now is the communication system. Okay. However, because he's heard of significant experience with signal-based systems, okay, this seems to be something that was in the past. I don't know, I didn't use them. Oh, let's go back. I didn't do those in the past, but we will see. He convinced the other elves that it would be okay to give you their one malfunctioning device. Surely you'll have no problem fixing it. As if inspired by comedic's timing. The device emits a few colorful sparks. To be able to communicate with the elves, the device needs to lock on to their signal. Okay, the signal is a series of seemingly random characters that the device receives one at a time. To fix the communication system, you need to add a subroutine to the device that detects start of packet marker in the data stream. Okay. And the protocol being used by the elves, the start of a packet is indicated by a sequence of 4 characters that are all different. The device will send your subroutine a data stream buffer, your puzzle input. Your subroutine needs to identify the first position where the 4 most recently received characters were all different. Most recently received were all different. Specifically, it needs to report the number of characters from the beginning of the buffer to the end of the first. Such 4 character markers. For example, suppose you receive the following data stream buffer. MJQJP. After the first 3 characters MJQ have been received, there haven't been enough characters received yet to find the marker. Okay, there are just 3 and not 4. Makes sense. The first time a marker could occur is after the 4th character is received. This would be this, making the most recent marker MJQJ. Because J is repeated, this isn't a marker. Okay, the first time a marker appears is after the 7th character arrives. This is this. Okay, because then we have JPQM. Okay. Which are all different. In this case, your subroutine should report the value 7. Because the first start of packet marker is completed after 7 characters have been processed. Here are a few more examples. Okay, so we have multiple examples currently. Okay, good. How many characters need to be processed before the first start of packet marker is detected? Okay, this doesn't sound too hard. Let's begin by copying over our examples, or at least at first our test cases. So we have 5 today, so we will store them in different files. So let's create a new file, call this test1.txt. Cancel coding. Okay. And then add this first. Let's create some other forms. Test2.txt. Edit. Switch over and copy. Next, new file test3.txt. Yes, we want to edit this. These. Test4.txt. Yes, and copy again from the browser. Sorry, I don't switch over to the browser automatically. This is something that I need to set up sometime, but I didn't so far. And every time doing this manually is a little bit too much work. So if someone of you has a good idea how to do this in OBS via some keyboard shortcut or something like that, just add a comment, would be really appreciated. Thanks. Okay, so we have our 5 test cases here. Let's start writing the application. So we have day 6 and a simple application. Yes, we want to edit. So, as usual, start by reading our file. So we have our input file, again some error, so it feels like a little bit repetitive. Oh, it's open, test1.txt, if r equals nil, then panic. Oh, no, and there's the first bug. Okay. So, now we need to think about how we read this. So it's other than in the previous puzzles, we don't need to read those files line-wise, right? Because every file contains basically just one line, so we read it until the end. At least we could do this, so make sure that we don't have a line break at the end of the file. I think this is better to be safe, but we will see. Okay. So therefore we can just read it directly. So the easiest option would be to read it letter by letter, or basically byte by byte, and then keep track of only the latest 3. So, and if we now that the one that we are currently looking at, or that we currently read, is included within the latest 3, then we know that the latest 4 have a duplication, right? So this is, no, it's wrong. No, it's correct. Yeah, I thought it was wrong because it could always happen that the marker was before, but this can't be because we would also already have been returned at this point. So let's start. Okay, let's say we have we store last, what do we call them, last symbols, and the last symbols is just a new slice of, not string, but what is it? Int 32, I think, was it? 32, and the size of it is just 3. Oh no, we can just keep it empty at the beginning, I think. This doesn't work, missing len. Okay, we have to provide it. Okay, then. Yeah, how do we read this from the file? For value or symbol, range input file dot, there's some way to read it. Read at, read from. We just need to read one single byte, one single value. This should not be that complicated. Okay, then we do it in a different way. We have our byte buffer where we read into. Buffer, it's a slice, also make slice of byte with size 1. and then we iteratively read into the buffer. Is there something like a while loop? Or some do repeat loop? We will see. So input file dot read. Here we read into our buffer. Red. And this is int and error. Yeah, this is correct. So it returns basically how many bytes were read, and then also optional error. So if equals not equals nil, then panic. So this is something to make the compiler happy. So, and then we just check. Let's make this into, oh. So, but we also need to store the position, right? So this is something that we need to do. So every time we have read, basically we change the position to the, and move it further to the by the number of bytes that we have read. So basically this would be this, and this would just read the first character. So, but now we want to do this until we are end of line, right? So let's see, how do we create a loop in Go which will basically running indefinitely? Let's take a look at our friend Google. Golang create loop while true. Is this something that we could use? They do not exist, but oh, for true. Okay, this is way easier than I thought. And then some break. Okay, we'll do this. So for true, we read individual bytes and then we will check if the last symbols contains already this byte. So buffer 0 current symbol equals. So, and now the question is, how can we check if something is contained within this symbol list? This is quite easy. Build a short function for that, where we contains, where we contains symbols byte and symbol a single byte, and this should be returning a bool. So within there we loop again for byte in range symbols, so looping over all the symbols that we have had in the past, and then check if the value of them is, or basically is equal if value equals our symbol. And if this is the case, then we return true. Otherwise, in the end, we return false. So this is quite easy. So, and now we use this, basically return if contains last symbols and our current symbol. So if the current symbol is matching, then we know basically we are at the position that where we detected a marker. So this means here we can end. Format.printf found marker at position and then our position is pos. Okay. And break. So now we would probably, I assume we run into some error when we are at end of file, but let's check it with our test. What happens first? Still forgot. We need to close our input file at the end. So, okay, trying to run it. Go build. Warning, has no effect. Yeah, okay. Panic EOF. Yeah, okay, this was clear. So we should check how does this EOF actually look like exactly. Then we can end gracefully, would be probably better. Error EOF. And red is 0. Yeah, of course. So if red equals 0, which usually means, okay, there's no more data to read, then we can break. Oh, one too far. And here. Okay, let's see how it works now. It should not panic in the end, but print out basically if it found something. Okay, it didn't print out anything, so this means, yeah, okay, I think we forgot one crucial part. So if we have this last symbol slice that currently doesn't contain anything, we also need to add the symbol that we read to it, right? Otherwise it doesn't work. So this is how we can do it. Basically, just after we read the current symbol, we do this and update last symbols. So symbols equals append. We append to last symbols just the symbol that we currently read. So far, so easy. The only question is now we only need to consider the latest 3, so therefore we should always try to trim it. So if we have more than 3 symbols in the list, then we can shorten it. So by removing the first, if len last symbols greater than 3, so this is then the case, for example, when we have 4 symbols in it, then we just say we want to take the last 3. This is something that we can do by last symbols is equals to last symbols, and then it will probably work like that we say, okay, we ignore the first one, because the first time this happens, it will be 4. We only add 1 item, so it should work for now. Let's see. Okay, found marker at position 4. This doesn't sound right, because as we knew from our puzzle, basically, it should be after 7, right? So why is it 4? Let's go back and look at why this is the case. Let's debug init. So we have read the first one. We had position 1. The buffer is so the current symbol is 109. Okay, and last symbols doesn't contain anything, so okay, it's appended. It's not greater than 3, so we just go to the next symbol. So now we are at position 2. Current symbol is 106. Last symbols is 109. We append, so we have 109, 106. Okay, so far so good. We go to the next symbol. It's 113. We append it, so, and we end up with this. Okay. We go through it, are now at position 4. Read the next symbol. It's 106 again. Ah, okay, and now I know what goes wrong. I think the definition was that it should not be contained. It should not be contained, and the length of last symbols should be 3. Because if you don't have read enough, equals 3, and it should not contain the current symbol, then font marker. Okay, let's start again. Font marker at position 5. Okay, better, but definitely not where we should be. So reread. We have position 1. Now we have, okay, let's check. So now we have 3 symbols in 109, 106, 113, which is okay. We don't need to reread the next one, which will be 106. And it's 106. So last symbols is equal 3, and it does contain, the last symbols does contain the current symbol, so therefore it's not going in there. It appends the symbol, which will be 106. Yeah, okay, and now I see the problem that I was mentioning way earlier. So now the problem is we read a new symbol, but the new symbol is not the one that is in there, but there are still 2 other symbols within our last symbol that are basically the same. So we need to change this contains method. So it's not about contains, it's more or less about has duplicates. Change this, so has duplicates, and then we basically do this differently. We has duplicates. We append it. Append it before so that it's of length 4. And when it doesn't have duplicates, then we should print we have found our marker. And then we basically strip it down. Hey!
Hey!
Sorry, I have to...
Was?
Alles gut, warte
Ich nehme
kurz.
sie sofort mit wieder raus, ich lege es dir nur hier hin.
Okay. Ah ja, super. Danke. Okay, so let's continue. Anna. Oh ja, lass sie hier. Ist okay.
Sicher?
Ja, ja, alles gut. Danke. Okay, let's continue. Where were we? Has duplicates. Yeah, okay. Basically, we add first all our symbols to it, and then we check if there are any duplicates in there. So this should not be that complicated. So how we can do this is we could, for example, use a map. We just convert it to a map of byte and and then already included. This is our new map. And then basically we add for each byte that we read in our symbols, we just add it to this map and check first if it's already included. If already included from value or symbol, let's call this now symbol. Then we can return true. Else, if it's not already included, we just set that it is included or set it to true. Symbol equals true. So, and now this should return true as soon as we have the same value or symbol multiple times within our string. Okay, let's rerun. Found marker at position 7. So this looks more like it. So this is basically the answer that we should get for this example. Let's try the other examples. Let's try example 2, run it, and we see it's position 5. Let's check. For this example, it's correct after character 5. Okay, so not wrong. Using next example, example 3, it's position 6. Okay, so the same as in the example that was given. For this is position 10. 10 sounds something wrong, but okay, it's true. It's position 10. Okay, and then let's now try to use the last example, and it's 11. Okay, it's 11 as given in the example. So this can make us quite confident that our solution is not wrong. So we need to create our input file. This is something that I didn't add, didn't request yet. So get your puzzle input. Oh, this is quite long. Okay, copy. And then add it here. It's one single line. Okay, so far so good. And now let's try to calculate. Okay. Run it. Found marker at position 11. No, okay. Input. We should also change the file to be the correct one. Found marker at position 1760. Okay, let's see if this is actually the correct result. Submit. Yes, okay. So this was easier than yesterday, definitely. We got our first star for today, but then directly look at part 2 of the puzzle. Okay, so your device, the device communication system is correctly detecting packages, but still isn't working. it looks like it also needs to look for messages. A start of message marker is just like a start of packet marker, except it consists of 14 distinct characters rather than 4. Here are the first positions of start of message markers for all of the above examples. Okay, it's the same, but just start of message. So we need to do have two lists basically. Okay, we go back and then we implement this a little bit differently, I would say. So what we can do is basically we have one list. Has duplicates is something that we can use again, but here we need to store more symbols, right? So we need to be able to store symbols that are way more than we need to store 14 symbols. So what we can do is basically just make sure that we store all the symbols, would be the easiest way, right? And then just make sure we consider only symbol the last 4 if we look for markers. So what we can do is just has duplicates and then put in here that we just use we just use a slice, a part of our last symbols slice to represent this. So last length from last symbols, and this -4 because it's about 4, and then we go to to the end, right? We read it till the end. So let's see if this still works. If we do it that way, then we don't need to basically remove something from it. Okay, it's still returning the same marker. This is the start packet marker. And now we use the same method for, we don't break, but we use the same method for detecting the message marker. Message marker. Okay. Yeah. So it finds a lot of packages, but the message marker is the more important one. But now check first our test cases that we have. 19. Message marker at position 19. Is this correct? Okay, yeah. Test 1 is message marker, start of message marker at position 19. Okay, check the next one. Test 2. Message marker at position 23. And we see 23 is also correct for the second test case. It's also for the third. So let's see if the third does also work. Test 3. Yes, it's also 23 also. And now test 4. Test 4 is 29. Okay, as expected. And now test test 5, 26, and also this is like the expected. So all the cases that we got, the test cases, are basically correct. This means we can switch over to our input.txt, run it, and then we have hopefully the correct answer for solving this puzzle. 2974. Let's see. Submit. Okay, and we got our second gold star for today. Good. With this, we are done for today. As always, you can find all the code afterwards at our GitLab repository that is linked at the stream or at our YouTube videos. So have fun trying to solve them by yourself. And as always, if you have questions or something, feel free to reach out. Bye, everyone.